All right, Tigers, here we go. Hope everything's going well today. Podcast for April 1st. Yeah, let's go. On practice elasticity problems and total revenue test. Okay, so just a quick reminder of where we were yesterday. We started to calculate PEDs, not steroids, but price elasticity demand. Remember we said price elasticity demand is greater than 1. Okay, it's elastic. And we talked about the details of that before. If the PED is less than 1, it's inelastic. If the PED equals 1, it's unit elastic. And we'll go over these points in a minute here. Remember, we said if it's perfectly elastic, horizontal point, price decreases all, QD reach infinity. Guys, look, pizza, bread, bottled water. Like, for instance, Monticello is going to be real popular tomorrow because apparently on April 1st, all the 5 Monticello's locations in North Hills are giving away 1,000 free pizzas. If you call in and said, Marty sent me, then from Marty Griff from the KDKA radio show, that'll get you to go. So, but as soon as, like, if one pizza's $4, one pizza's $6, people are going to buy the $4 pizza because pizza's pizza. Something that's perfectly inelastic where there's a vertical line, Super Bowl tickets, people are still going to buy even if the price goes. So where we're going to go here, guys, I have a couple practice problems here. And there's 2 ways to do and calculate elasticity demand. And the first way is to use this idea of the new and the old. Okay? So what we're going to do is we're going to use the information in front of us. Okay? You take the new quantity minus the old quantity over the old quantity, and that'll give you a percentage. Then you take the new price minus the old price over the old price. That'll give you a percentage too. And that's our percentage change in quantity divided by our percentage change in price. And that'll give us a decimal. So what we're going to do is let's see if we can set up the problem correctly. So I'm going to pause the recording here and see if we can set this up. Ready? 3, 2, 1. Okay, so here we go. The new price is 8. The old price is 10. I'm sorry, the new quantity is 8 boxes. The old quantity is 10. Put that over 10. New quantity is 375 minus 3. Put that over 3. And now we can start to calculate out how this goes. Okay? So the question is Julie's demand for envelopes elastic or inelastic? And then what is her elasticity demand? Okay, I want you to see if you can calculate this answering these 2 questions. 3, 2, 1. Okay, so you take 8 minus 10 over 10, that gives you 2. 2 over 10 gives you 0.2. 0.75 over 3 is 0.25. 0.2 divided by 0.25 is 0.8. So that tells us, guys, that the elasticity of demand is, if it's less than 1, it's inelastic. Right? So we're good to go. Now, let's try this problem over here in terms of, this is a really good one. Okay? Frank is buying hot dogs. It's constantly 0.9. So we know that this is 0.9. And he buys 4 hot dogs when the price is $1.50 per hot dog. How many will you buy? The price is 1. So the question is, how many hot dogs is he going to buy? So we're looking for this new quantity up here. And we have pretty much everything else. So I'm going to see if you can set it up and go. Set it up just like this. And I'm going to work it out for you, and I'll show you the answer in a minute. Ready? 3, 2, 1. Okay, did you get it? Did you get it? Okay. X minus 4 over 4, 1 minus 1.5 over 1.5, right? Start reducing. X over 4, 0.5 over 1.5, x over 4 is 0.333, right? Okay, cross multiply, x over 4 divided by 4 equals 0.9 divided by 0.3. Okay, it's 33%, just round at that point, right? Which gives me 0.3. Okay, x minus 4 divided by 4 equals 0.3. Cross multiply again, x minus 4 equals 1.2. Move the 4 over, x is 5.2. So that sort of makes sense, that if the price goes down from 150 to 1, he's going to buy more hot dogs. That's how it works at that point, okay? Good couple of practice problems there to see. Okay, reason why we do this one at this point is this. Look, this looks like, if we go back to our diagram from here, okay, we said that if it looks like an eye, it could be inelastic. If it's flat, it could be elastic. Okay? So what we're looking for really at this point is, how do you calculate? Let's do one more here, okay? Let's calculate the PED of good 1 and the PED of good 2 and just see where it is, okay? Calculate in 3, 2, 1, pause. Here we go, right? Hi, Bobby. Dog walking. Over here. Okay? 102 minus 100 over 100. 18 okay, new minus the old over the old. New minus the old over the old, right? Quantity, price. 2 divided by 100, 2 divided by 20, 0.02, 0.1, 0.2. Okay? But that looks like we're really flat line. So we know that if it's under 1, it's inelastic. Right? Okay, over here. Okay? 20 minus 15, okay? New minus the old over the old, right? 20, okay, and then 18 minus 20 over 20, right? Okay, new minus the old over the old, right? 5 over 15, 2 over 20, 0.3 over 0.1, 3.33. Even though it's a very steep line, in this case, it's elastic. Okay, so how do we see this move upward here? Okay, remember, greater than 1, let's go back and look, right? Greater than 1, elastic. Less than 1, inelastic. Okay, greater than 1, elastic. Okay, less than 1, inelastic. Right? Elastic. Inelastic. Inelastic. Elastic. Right? Okay, what about the demand for insulin for diabetics? Probably a pretty steep curve there. If you have diabetes, you're going to need insulin. So my guess it's a very inelastic demand for that good. Masks, face guards, all the things that are going on now during this coronavirus pandemic are very inelastic goods. Okay? It would be interesting to look at the elasticity of gasoline right now because not as many people are driving right now. So it would be interesting to see, especially with these price drops, if the good's becoming a little more elastic. I don't know. We'll see. Okay? Okay, which of these goods have a more elastic demand, right? There you can see the change in the prices. Prices are going up. Quantities are going down, right? By which amount would make this more elastic? When the price changes, you're not buying the same quantity. Here, when the price changes, okay, between these two, pull the pen up here, right? Okay, price changes, goes up by $1, you lose 10. Price goes up by $1 of gadgets, you lose 20. So which one's more elastic? I'm hoping you're able to say easily gadgets at that point. Okay, hoping. Okay, why is it important for our producers to know if their goods are elastic or inelastic? Because here's the big key that we're going to get to, guys. Okay, at particular prices, and we're going to get to this point. Okay, because if your good is inelastic, you should have the opportunity to raise prices. When it's elastic, when you have an elastic demand, you shouldn't touch the price at all. In fact, you may want to lower it to a point. We'll get to that later. Excuse me. Okay, so why is this relevant? This all pops up with the total revenue test. So there's a cheaper and an easier way to do this than to go through and calculate. If you have price and you have total revenue, there's an easy way to do this. Okay, so here's what happens. Okay, here's price. Okay, let me do it this way because I'm going to do it reverse view, right? The price arrow is going up. Okay, the total revenue arrow is going down. So what's happening? Well, look at the dance move, right? What's happening is the arrows are going in opposite directions. Okay, or price is going down and total revenue is going up. Notice that the fingers, the dance move, are going in opposite directions. When the arrows are opposite, price is going up, total revenue going down. Price is going down, total revenue going up. It's elastic. I'm going to show you how this works in a minute. Don't worry about this unit elastic right now. We don't need that. But over here, when price is going up and total revenue is going up and you're getting this dance, oh, look at that. It's great, right? When they're both in the same direction, it's inelastic. Okay? So let's see how this works in a minute here, okay? By the way, I apologize for a little bit of Taylor Swift in the back, but it's keeping the 4-year-old entertained. Okay, here we go. Price goes from 5 to 6. Okay, quantity demanded goes from 15 to 10. Okay, so if you have price and quantity demanded, then you can get total revenue, which is what we need here. Okay, so ready? Where's my little arrow guy? Here he is. Okay, here's my little arrow guy, right? What's happening to price? Price is going from 5 to 6. Okay, so let me type this out so it's a little bit easier. Well, I'll just use these down here. Okay. price goes from $5 to $6. So the price is going to increase, right? 5 times 15 is 75. 6 times 10 is 60. Okay? So what happens to total revenue? Total revenue goes from 75 to 60. Okay? So the total revenue went down. Okay? Price up. Total revenue down. They're in opposite directions. It's elastic. Dog. Okay? Let's do the second one together. Okay? Price falls from 10 to 9. Okay, I'm going to bring my little word guy out here. A little bigger here. Okay. Old price, 10. Okay. New price, 9. Quantity demanded goes from 100 to 110. Okay. 10 times 100 is what? 1,000. Okay. 9 times 110 is 990, right? Okay. So what happens to price? Price goes from 10 to 9. Price goes down. Okay. Total revenue, 1,990. Total revenue goes down. Therefore, the good is, they both are going, look, they're both going down. What's the good? It's inelastic. Okay. Guys, in econ, this total revenue test will save your tushes like you can't believe. Okay? In college econ, AP econ, whatever the case may be at that point, there's always going to be some question with regard to elasticity. Okay? And this is really important to get to that point so that you have it. Okay? Let's see, is there anything else? Okay, one more problem. Ready? I'm going to move me over here. Okay. All right. Now, we can calculate it, right? Change in quantity over the change in price, right? We can do this, but why? What's happening to price? Price is going from A to B, right? Okay, price is 10, now it's 5. So we know price is going down, right? What's happening to total revenue? Well, total revenue is 1,000 to 1,125. We know that total revenue is going up. Our demand is, if they're opposite, right? Our demand is elastic. And I don't know why it's so small. Let's hulk that guy up. Let's steroid that guy up a little bit here. 20. That's better. Okay? If you have any questions, send me an email. Focus tomorrow will be on the elasticity of the demand curve and leading into a couple other things with regard to calculations going forward and total revenue. Okay? I wish you nothing but the best. Stay safe. Go Tigers.